All incremental value of an IoT product comes from transforming its data into useful information. Analytics transforms the data, and as such, is of critical importance to every IoT deployment. Analytics has been used well before IoT, but one of the biggest differences in using analytics in IoT is the size of the databases. These databases are often time series based. So by nature, this is big data. Consider the number of sensors, and they can be thought of as the columns in a spreadsheet. Then time equals 1, 2, 3, 4, they can be thought of as the rows in a spreadsheet. Depending on the fidelity of time measured, whether that's 1 per second, 1 per minute, 1 per hour, over time, these will produce very large data sets, and in fact, are the definition of big data. All this data, or big data, is stored in databases. Metaphorically, in IoT, we like to use water. So we have data streams that feed into data lakes, which are databases, and then are redirected to data pools, which are portions of databases, to be worked on by analytics. There is a direct relationship between the digital twin and analytics. In fact, the structure of the digital twin defines the structure of the analytics or the data science. The digital twin consists of two parts, the data and the model. The raw data comes in from sensors in a time series form and is from also external systems in an unstructured form. This raw data is analyzed by analytics for a couple purposes, one of them being to create models. Models are created to simplify the data so we can again apply more analytics in a more simplified form. It's not practical to apply analytics to millions and millions of points of data. This is why we need to create the model. Once we have created the model with data analytics, we then use data analytics on the model for further analysis. This always starts by creating the model, then improving the model, and then comparing that model with other models to provide insights. The digital twin is everything that analytics needs. It consists of a federation of data and the models. Federation means that all the data and the models do not need to be stored in one database. Instead, we point to different databases. It should also be noted that there's not going to be a single digital twin for an IoT product. There will be many different digital twins. They can be at the part, the product, the system, or in the environment level, and they can also be used to provide different forms of functionality. The structure of the digital twin is hierarchical, and as mentioned before, it defines the data science structure. This is why you always start by defining the digital twin technology-wise when designing your product. And remember, we always start with value. What's the value we need to create? What's the information we need to create that value? Then, what data do we need to create the information to create that value? And then, what technology we need to capture that data, store that data, in order to create that information to create that value. This is where the digital twin comes in. It again defines the structure for data science. A good question to ask is, well, where is the data analytics? Well, analytics is computed anywhere on the network fabric. Data is also stored anywhere on the network fabric. So the analytics can occur on the embedded system to do so-called miscomputing. It can be on the fog, so that would be in the gateways on the OT network or the IT devices such as firewalls and switches in the IT network, or it can be performed on big servers in the IoT cloud. With the exception of real-time analytics, which needs to be calculated close to the source, generally analytics is an external system, and this external system uses high-performance computing, often parallelized, to perform the heavy lifting, when doing analysis that looks into the past or into the future. And this is a useful way to classify analytics: the past, the present, and the future. In the past, we ask the questions, what happened? And why did it happen? This is answered by descriptive analytics and diagnostic analytics. In the present, we ask the question, what's happening now? That's answered by rules engines and stream processing. And for the future, we ask the questions, what could happen? And what should happen? That's answered respectively by predictive analytics and prescriptive analytics, all of which we're going to be talking about next. Whether looking into the past, present, or future, the starting point for analytics is creating a model to the data.